Well, well, well. All right, so you're here for another lesson, are you? Lesson 2-8. We're going to convert from standard form to slope-intercept form. So we've been talking about slope-intercept form. That's when y equals mx plus b. It's called slope-intercept form because it has the slope and the y-intercept. This is just one of the many forms that we could write a linear equation in. This might also be called graphing form sometimes because it's the easiest format to graph an equation in because it gives you the slope and the y-intercept, and that's all you really need to graph is the slope and the y-intercept. But that's not the only form of linear equations. You can move stuff around into something called standard form. Notice in slope-intercept form, y is isolated, it's by itself. Everything else is on the other side of the equation. Standard form still has x's and y's and still has constant values, but in standard form, the x and the y are on the same side of the equation instead of the y being isolated. So it's just a different form for a linear equation. It still has an x, still has a y, that's making it a linear equation. But on this one, the x and the y are on the same side of the equation. Now, if we want to graph, we do not want it in standard form. You could graph with standard form. It's just not as easy. So we're going to usually want our equations in slope-intercept form before we graph it. So here we go. We're going to convert these into slope-intercept form by isolating the y variable, getting y by itself. And it's kind of like solving equations that we did in Unit 1. We're going to use inverse operations so that we can get them into slope-intercept form. I want to isolate y, so y is going to stay over here. So how do I get rid of positive 3x? I simply subtract 3x from both sides. I'm going to subtract 3x from this side. I'm going to subtract 3x from this side. Now, over on this side, the y's have now canceled, or the x's have now canceled each other out. I am left with y. I have isolated y. There is much rejoicing. That is my goal, so I have achieved my goal. Now, what do I have on the other side? I've got 15 and negative 3x. Can I combine those? No, they're not like terms. So I can't combine them. So I'm going to write negative 3x first and positive 15 second. It is now in slope-intercept form. Slope is negative 3, y-intercept is 15, and there's much rejoicing. Next one. Similar to the last one, we want to isolate y. Also similar to the last one, I want to move this x first. This is positive x. How do I get rid of positive x? By subtracting x. So I'm going to subtract x from both sides. All right, once I've done that, on the left side, the x's are reduced, and I'm left with negative y. Again, these are not like terms, so I'm going to write it as negative x. Oops, wrong color. I'm making poor choices. Negative x plus 3. But I am not done. I have not isolated y. Right now, y has a negative 1 in front of it. Isolated means that there's nothing in front of that. So I need to use my multiplication property of equality, which means that I can get rid of this. Since it's negative 1 times y, I can divide by negative 1 so that I can get the y isolated. So that would give me a y over here. Now the problem becomes, if I divide by negative 1 here, I cannot just simply pick and choose which one gets divided by. I can't just go, oh, I'm just going to divide this one by negative 1. No, the property says if you divide this side by negative 1, you have to divide this side by negative 1. Not just one part, but all of it. I have to divide both of those by negative 1. Because the property of equality says if you do it to one side, you have to do it to the entire other side. So if I'm dividing this side by negative 1, this whole side, so every term gets divided by negative 1. So negative x divided by negative 1 is positive x. And then 3 divided by -1 is -3. It's now in slope-intercept form. My slope is 1. My y-intercept is -3. Let's keep on doing them. We've got 9 of these, so this might take a little bit. Again, first step, we're going to subtract 4x from both sides. Subtract 4x from both sides. The 4x reduce. I end up with 2y on this side. On the other side, not like terms. So I just write -4x plus 16. Y is not isolated. There's a 2 in front of it as a coefficient. So how do I get rid of 2 times y? I divide by 2 because I'm a good person. And remember, if you divide this side by 2, the entire side divides by 2 over here. What am I left with? Well, those reduced. I get y equals -4 divided by 2 is -2x. 16 divided by 2 is 8. -2x plus 8. I can now see that my slope is -2, my y-intercept is 8. 6 more. All right, so if you're just kind of following along at home, you should probably practice some of these. Maybe if after I do like the first one, you try the other 2. All right, let's try the next one here. So for this one, following along from home, I'm doing a pattern here. I'm going to add 12x to both sides. Have you seen the pattern of how I do this? I usually move the x first, the x term, and then whatever the coefficient of y is, I get rid of that. So that leaves me with -3y equals 12x plus 15. So there's a little bit of a pattern here. I move the x term, and now I get rid of the coefficient of y. I divide everything by -3. Not just one thing, everything. The property of equality says everything gets divided. So over here, -3 divided by -3 is 1, so I just get y. Y is isolated. 12 divided by -3 is -4x. And 15 divided by -3 is -5. So my slope is -4, my y-intercept is -5. So at this point, if you're feeling saucy, you can go ahead and try to do these next 2 problems. So pause it if you want to. There we go. All right, so I am going to follow the pattern that I've been doing here. I'm subtracting x from both sides. I move the x term first. I get 2y equals, these are not like terms, -1x. It's either -x or -1x. You can do it either way. Minus 10. Not like terms, couldn't combine them. Now I'm going to divide everything by 2. Remember, this was -1x. So these reduce. I get y equals. This does not reduce. It's 1 over 2. So I just get -1 over 2x. -10 divided by 2 is -5. So my slope is -1/2. My y-intercept is -5. Number 6, again, I'm following that pattern of moving the x term to the other side by using inverse operations. We subtract 3x from both sides. That leaves us with -4y equals -3x minus 12. And now, following the pattern I've done with all these, I'm going to divide by -4, the coefficient of x. So I'm left with, on this side, y. I have isolated the y, which is what I wanted. Now I have to start reducing everything over here. So 3 and 4 do not reduce, but they're both negative. So that becomes a positive 3 over 4. A negative divided by a negative is positive. So my slope is 3/4. And then -12 divided by -4 is positive 3. So the slope is 3/4. My y-intercept is 3. Almost there. All right. Maybe if you're following along at home, maybe you're sick today or something, you're just watching because you're bored. And do they even have like, what do you call those, like game shows? When I was sick, I always watched like, we will watch like The Price is Right, Family Feud. I guess they don't have those anymore. Whatever. So, I don't know what you're doing at home, but I'm glad you're doing math. Math is great. So we're going to subtract 9x from both sides. It's late in the day. I am just blabbering at this point. All right, so we subtract 9x from both sides. We get negative 6y equals negative 9x plus 18. Sounds great. The pattern that we've been seeing is I've moved the x term to the other side using inverse operations, and then I divide by negative 6 using the multiplication property of equality. All right, remember everything is divided. Everything's looking great. I get y equals. Now I need to reduce this. A negative divided by a negative, that's positive. But 9 and 6 doesn't go into 9, but I can reduce that fraction. 3 goes into 3 9 times. Now, 3 goes into 9 3 times, and 3 goes into 6 2 times. It is getting late. I think this is going to be my last video tonight. Finally, 18 reduced by negative 6 is negative 3. All right, 2 more problems and I'm going to go home. All right, so practice. We're going to add 4x to both sides. There's a pattern emerging here. We get 16y equals, these are not like terms, 4x minus 32. I'm going to get rid of the coefficient of y by dividing by 16 on both sides. Delicious. So 16 divided by 16, they're gone. I've isolated y, which is the whole point of this. Now, watch out for this one. The number on top is smaller. 4 divided by 16 is not 4. You have to reduce both of these. 4 divided by 4 is 1. 16 divided by 4 is 4. So 4 over 16 does not become 4. It becomes 1/4. The denominator is bigger. So we should have a small number here, a fraction. And then 16 does go into 32 twice, so we get negative 2 there. Everyone was kind of saucy. All right, last problem. The pattern is we've been moving the term that has the x in it, the x term. Negative 42x gets moved. I get negative 14y equals negative 42x plus 42. All right. Oh, okay. Divide both sides by negative 14. I don't think I meant both of these to be 42. We're just going to write this one out. It's going to be fun. All right, so negative 14 divided by negative 14, we get y equals 42 divided by negative 14. 14 goes into negative 42 3 times. I definitely didn't mean for that to happen. Oh well, we're just going to go with it. So we end up with 3. 14 does go into 42 3 times. Negative divided by negative is a positive, so we get positive 3x. 42 divided by negative 14. Ooh, now we have a positive divided by negative. This is going to be negative 3. I think I didn't mean for this number to be 42. I think I wanted it to be 49 instead. Oh well, maybe I'll change it for my students in class. Whatever. It's good. All right, there we go. We've got that. Lesson 2-8. I'm going to go home. I'll do lesson 2-9 in the morning. All right, I will see you guys later. Math hard. Bye-bye.